Dear children, today we are going to solve example 11. Show that 3 root 2 is irrational. As we have done the previous problems, same way we have to assume the given one as a rational number. The proof is, let us assume that 3 root 2 is rational number. If it is a rational number, then it should be of the form p by q. So we have written 3 root 2 is equal to a by b, where a and b are integers and b is not equal to 0. Now these integers we have taken as coprime numbers, where a and b are coprime. Coprime means HCF is 1, that is only 1 is a common factor. And b is not equal to 0, that means the denominator should not be equal to 0 for a rational number. So now root 2 is equal to, this is 3 root 2, the 3 into root 2. So when it comes to the other side of the equal to sign, it becomes division. So 3 comes in the denominator, a by 3b. Now you know a and b are integers. If a and b are integers, then a by 3b is also an integer. So now here a by 3b, it becomes a rational number. Since a and b are integers, then a by 3b is a rational number. Now if this is a rational number, it is equal to root 2. That means this also is a rational number. So root 2 is also a rational number. But we know that root 2 is an irrational number. So this contradicts the fact. But this contradicts the fact that root 2 is irrational. So this cannot be a rational number. It should be an irrational number. So our assumption is wrong. That means we have assumed this to be a rational number in the beginning. So our assumption is wrong. So what is the conclusion now? Hence 3 root 2 is irrational. The next is exercise 1.3, first problem. Prove that root 5 is irrational. Same way, let us assume root 5 is rational number. As we have done root 2, root 3, the same method. Then root 5 is equal to a by b, where a and b are coprime, b not equal to 0. Now I just cross multiply this, b into root 5. So it becomes b root 5 is equal to a. I told you only when for root 2, root 3, root 5 we have to follow all these steps. So b root 5 is equal to a. Now in order to remove this root, we are squaring on both the sides. So when we square on both the sides, b root 5 the whole square is equal to a square. What is b square? B square as it is. Root 5 square is 5. So 5b square is equal to a square. Take this as first equation. Now I told you the previous problem as we did for root 2 and root 3. B square is equal to a square by 5. Okay. So now we can understand from this 5 divides a square. If 5 divides a square, I told you automatically 5 will divide a. So 5 divides a square implies 5 divides a. So take this as second equation. So we can write a is equal to 5c. So any integer c, for some integer c. Now we are substituting a is equal to 5c in equation 1. What is equation 1? 5b square is equal to a square. So now 5b square is equal to, instead of a, I am writing 5c square. So 5b square is equal to 5 square is 25, c square it's as it is. So now 5 ones are 5, 5 5s are 25. So left out is b square is equal to 5c square. Now this implies, I am just interchanging the places, 5c square is equal to b square. Now if I want c square, what is c square? B square by 5. So now 5 divides b square, that means 5 divides b. Take this as third equation. Now the second equation, we found out that 5 is dividing a, and this equation we find 5 divides b. That means 5 is dividing both a and b. So from 2 and 3, a and b have at least 5 as a common factor. So 5 is dividing a and b. We have assumed that it is a and b are coprime numbers. But now we can see a and b is having 5 as a common factor. That means they are not coprime. So but this contradicts the fact that a and b are coprime numbers. So what we assumed was coprime, but last we are getting as it's not coprime number because it is having 5 as a common factor. What is coprime? That is no common factor other than 1. So our assumption is wrong. Hence root 5 is irrational number. Next question is prove that 3 plus 2 root 5 is irrational. I have told you if this type of sum come in 4-mark question, we have to prove root 5 is irrational in this method. Then we have to do this. Or if it is coming in 2-mark and 3-mark, we need not do that method. Only just we can prove as we have done now. Let us assume that 3 plus 2 root 5 is rational number. Then 3 plus 2 root 5 we have to take it as a by b because it's a rational number. A and b are co-prime numbers, b not equal to 0. Now I am keeping 2 root 5 as it is here. I am bringing 3 to the other side. A by b minus 3. Now when I take LCM, we get 2 root 5 is equal to a minus 3b by b. So root 5 is equal to a minus 3b. 2 root 5 this is 2 root 5. So when I bring it to the other side, I get division. So a minus 3b by 2b. Now you know a and b are integers. Since a and b are integers, a minus 3b by 2b is rational number. So root 5 is also rational number. So if this is rational number, this also should be a rational number. So both are rational numbers. But we know that root 5 is irrational number. So but this contradicts the fact that root 5 is irrational. Therefore our assumption is wrong. Hence 3 plus 2 root 5 is irrational number. Thank you.